Hello, everybody. My name is Jim McMahon, and I represent Group C for the Fall 2021 SYST 542 class. Today, we'll be walking you through the first draft of our optimized portfolio Excel model. What you're looking at here is actually the dashboard that's eventually going to be used to generate our portfolio. We'll actually start with the low-level data tabs and work our way back up. Looking at these gray tabs, this first tab shows all of the stocks in both the Dow Jones Industrial Average and the Bombay Stock Exchange Nifty 50. If I scroll down, you'll see there's all 80 stocks here. We break out the Dow Jones 30, the Bombay 50. That's just for informational purposes. You can see all your pricing, you can see your levered beta. We'll start getting into some average 3-year returns and some of these other tabs, but moving to the very high risk tolerance set. This is actually getting into something that's going to support our model. The user will have the chance to qualitatively define their risk tolerance between very low, low, neutral, high, and very high. So this very high risk set actually just includes all of the stocks. You see some returns on the right here, which will be the same for all the other tabs. We go to the high risk. We remove only one stock. We move to the neutral. We start removing more. We're down to 73. Go to low, we're down to 57. Go to very low, we're down to 32. These removals are completely based on this levered beta column in column J. We split the range of our levered betas in the universe into 5 equal buckets. Those buckets then decide what's in each risk tolerance set and what will appear depending on how the user defines that risk tolerance in their model. Moving up a little bit higher, we have some statistics. These are just super high level statistics for anybody who might want a quick look at some of the information in those data sets. We can look over 3 years. Coal India did the worst. They actually lost a significant amount of value over that time. Tata Steel did a little bit better, actually much better than the max 3-year return of almost 80%, which is very high. And then you can kind of see, closing price min and max. We can see some levered beta information. But more importantly, we can see how we define the levered beta buckets. So we had our low levered beta of 0.39. We had our high levered beta 2.32. These are actually both shown over here if you're interested in seeing what those stocks were. But that kind of defines how we handle our risk tolerances. Getting into the data wrangling and actually supporting our model, these securities you see here in this little table are based on what you see in C2. So right now we have it defined as neutral, and this is actually pulling from our dashboard. So if I were to go back to the dashboard and switch neutral, let's make it low. You can see that this also changes, and these are going to change as well. So right now you'll see for the low, we only have 51 stocks. Change it one more time. Let's go very low. Next thing you know, we're down to 28 stocks. You might notice that number of stocks is lower than what was shown in the data tabs. This is because this table automatically sorts based on best return and does not consider any stock that had a negative return over that 3-year period. The idea of it being that when we invest our money here, we do not want to put our money anywhere where it would be lost. We want to go somewhere where we had a positive return over the past 3 years on average. This levered beta column, you'll notice we have pretty low levered betas here. This is because our risk tolerance is very low. If we were to change that, stocks that had higher levered betas would be acceptable in this table, and they would also be auto-sorted. The way we do this was through a custom Excel function that was built in VBA called nth largest. This actually goes ahead and sorts these things and checks to make sure they're not negative. And then all these other informations in these columns over here are just index matches. And we have a little if error statement, so instead of getting a bunch of errors down at the bottom of the table, if there's no stock there, we just get a little NA. Moving on to the user dashboard, this is kind of the bread and butter of the model. You see this table's empty right now, but we defined our risk tolerance. We have our $10,000 of available funds as defined in our project. We could actually change this number to anything and it would still work. Say you wanted to do 100K, we would be able to distribute that out the same exact way it works with the 10,000. So let's keep our risk tolerance at very low and hit find optimal. You'll see it comes up with 12 stocks. The way this worked out with our average returns, there's always going to be 12 stocks in this model because there's always 12 stocks that provide a positive return even on the very low risk tolerance. We actually do handle the diversification through a VBA script. So the diversification definition was you cannot have more than 60% of any particular index represented in your portfolio. So you can't have more than 60% BSE, can't have more than 60% Dow Jones. As you can see, as we get to the bottom here, 4 Dow Jones in a row, it recognized that we were going to have 60% BSE already, and we can't go any higher. So it was only considering Dow Jones the rest of the way. To show kind of the little helper column that does this, you can unhide here. You'll notice column H. This is the same order as it appeared in the data wrangling tab, that blue tab we were just looking at. We get down to 8. It realizes we have enough Bombay Stock Exchange stocks, starts looping through, sees that the next 3 were also Bombay stocks, and then when we got to 11, we got to another Dow Jones. And then we got to our 12th stock, and we can't have more than 12 based on our optimization parameters, so it stops here. You can rehide column H. Now this shows the best possible securities under our definitions, but doesn't actually show any dollar values. We get a little bit of high-level statistics based on the optimal portfolio, but scrolling to the right, we see we have kind of the initial cut at our actual dollar allocations that we're going to use in our final model. These are those same stocks shown on the left in that left table. All the same information, just index matches. Now we're going to look at how do we actually allocate our dollars. And what we want to do here is calculate a ratio that is our return versus our levered beta. The idea here is that the higher your return is compared to your levered beta, the more money we want to allocate to that stock, because a lower levered beta indicates a lower risk stock compared to the market. And if we have a very high return compared to our levered beta, that's where we want to put our money. So we use that ratio and create a little cumulative distribution. What's happening here is we have that return to beta ratio. It's compared to the sum of all of those. So you can see sum P5 to P16. And it gives you a percentage of the total for each one. And that kind of tells you how we want to allocate our money. Where's our best return and our lowest risk? Looking here, we have the stock price. This is actually pulled from those original data tabs we were looking at earlier. We can figure out how many shares that we've bought based on our percentages in the stock price. So this is just, the price of the stock times how much we're going to buy over, the actual total price of the stock. And you can figure out how many shares that is. Price times the shares gives you a total value of that purchase. And there's your total $10,000 down here. So we were able to spend all $10,000 of our dollars. There was always a way to increase value there. And that's our optimized portfolio. Some things we want to do in the future, especially for P4 and P5 of this project. You see there's some blanks down here on this table. We would like the user to be able to maybe have a little drop-down menu in this ticker column for these and add in their own stocks, even if it goes over the count of 12 that we automatically generate. We would also be interested in allowing the user to remove certain stocks from the top. All these stats would be the same. They would just be calculated based on whatever shows up in the table at the time. Get a little peek under the hood. These buttons here, find optimal, clear table, are actually tied to macros. Find optimal is probably the more complicated of them. Clear table is like a very, very short macro. This little placeholder here, we're thinking about a couple of options for it. It might actually call a solver and help optimize this portfolio a little bit more efficiently. We can take a little peek at the VBA code that goes into this. You'll see here, this is the clear table macro, very short, just clears those cells. They do tie to these specific worksheets, so the worksheet names are important in these macros. This is our custom function, nth largest, takes a little bit of input, ensures everything works as intended. A little bit of error handling here. This is actually going to spit out a huge number if something goes wrong, so it alerts the user that something's wrong. And then optimized portfolio, this is actually tracking to make sure we meet our diversification requirements, and ensures we don't go over the 12 total securities. Thank you very much for your time, and have a great day.